All right, welcome everyone to the April 4th, 2018 SIG Auth community meeting. It looks like we don't have any announcements for the week, unless anyone has anything that didn't make it to the agenda.
The only one I had was that the calendar invite got updated, but if you're here in the meeting, then you probably already know that. So if you are not on the SIG Auth list, add yourself to that list and you should get meeting invite notices now.
Great, thanks for that. Anyone else? Going once, going twice? All right, let's move on to our demo. Our demoer is on the call.
Yeah, we're here. Do I need? I guess I need to share my screen. I've actually never done that with Zoom, so I have no idea if it'll actually work.
Do I need to stop?
Yes.
Sharing my screen for that to work?
Yep.
Okay, great. Take it away.
Can you guys see the GitHub page with Citadel?
Yes.
Okay, cool. Nathaniel, you want to answer based on some of our initial conversations?
Yeah, so basically I've been doing a threat model review internal to Red Hat. And out of that, we identified one area for improvement to be to implement the KMS interface that landed in Cube was 110
as an alpha feature.
Yeah, and but one of the things that we realized was that we had a lot of systems we wanted to integrate with that did not have easy access to gRPC for a variety of reasons. And we also identified that basically the workflow for all of them was pretty much the same, which was that we needed to have access to a key encryption key, and we needed to perform encryption using that key encryption key. We needed to cache it, and then we needed to periodically refetch it. So, so what we came up with was this app called Citadel, which basically does the gRPC bits to Kubernetes, and then will execute a command that the administrator can specify in order to fetch the key encryption key. And then it does all of the encryption stuff internally and will periodically refetch the key encryption key. One particular example we gave there is with the Red Hat project called Clevis, which is a project for doing automated decryption policies that are cryptographically verified rather than being a special process which can make decisions. So that's one particular implementation, but you can plug your own implementation in here. There's nothing specific to the Clevis project. So I think that's pretty much it.
Yeah, so another example, which we haven't necessarily added, would be like HashiCorp's Vault. The ability to fetch a key from them would work just as well. Otherwise, let's see if you guys now see a terminal. I'm hoping that if I just move Windows.
We do.
Around. Okay, cool. So I have a little cluster, Kubernetes cluster that is configured to use the KMS interface, and then this little file has a presumed secret key, which is obviously not secure. So as just a little demo, so we do support systemd socket activation with Citadel, so that kind of makes it easy to start it. So now it's listening on that socket. If I was to go over here and actually start up, start up Cube, and then go back here, we will notice in the not too distant future, something show up here, which is along the lines of Cube is connecting to it. I can tell Zoom is really slowing down my machine because it does not take this long normally. So now the Cube is connected. It will try to actually encrypt the secrets, but that's so it is going really slow. Okay, there's my secrets. So we have some secrets in etcd, right? So one of the fun ways that you can see that this is actually doing something is if I come back over here and kill systemd, and then go back to this, you'll notice that it can only like decrypt a partial list. I'm actually surprised it couldn't decrypt more. I might not have fully cached some stuff. Normally it can do 3 because that's like the cache policy I set on the config. I think that's just Zoom slowing it down. So if I was to go ahead and restart systemd, and then we'll wait here for a few seconds, presumably
Cube is going to reconnect to this as soon as it gets pre-CPU cycles.
yes. And wow, this is surprisingly slow. That will happen. There we go. Okay. So now if I go back, I can see secrets again because they can be decrypted again. And then as just a proof that things are actually being are encrypted, if we create a secret while we had a watch going, we will see that we can see the envelope prefix, the name of our KMS, the size of the data encryption key, a prefix that Citadel adds so it can figure out what it did with your stuff, and then the data encryption key and the actual stuff. So I think that's it.
Yeah, that's pretty much it.
Any thoughts, questions, concerns, comments?
Looks awesome.
Yeah, that's really cool.
We haven't measured performance yet, which is one of the things we need to do. We want to understand exactly what the performance hit is of enabling the system. So one of the things we did is we have a secret no-op mode where it will just pass back plain text to KMS or through the KMS interface, so that we can just measure the raw impact of going through the entire KMS interface.
I'll probably put some debug stuff into Cube to kind of play around with it. So,
cool.
Right, I will share my screen now. I think that's all we got. Thanks, guys.
Yeah, thanks for that. So moving on to some polls of note. I just wanted to call out the scheduling policy proposal here. I think we've discussed it before. There's been some conversations with the policy working group, and we had a discussion at the SIG architecture meeting as well about having a kind of broad guidelines for how all of our policy objects in Kubernetes should work and relate to each other. And there's kind of a larger discussion of what policy should actually be within Kubernetes as a first-class resource, as opposed to delegating out to third-party integrations such as Open Policy Agent. But the reason I wanted to call out scheduling policy here is I think that's kind of the next policy that we're going to be adding to Kubernetes as a first-class citizen. And so this is becoming a bit of a place for us to start laying out what shape we want policies in Kubernetes to take in the future. So things like how policies are composed, how we handle defaulting, how policy gets bound to the resource. And some of the questions that I was trying to tackle in the pod restriction proposal that we discussed recently. And also, just to mention the pod restriction proposal, I'm probably going to disband that and take a lot of the recommendations from that and apply them to the scheduling policy, and then eventually we'd like to turn those into an actual guidelines for how all policies should work, and eventually update the existing policies to conform to that. So there's ongoing discussions around this in the policy working group if you're interested in getting involved, or you can comment on the scheduling policy PR, and yeah, that's all there is to talk about there. Any questions on that?
So have you deprioritized combining all pod-related policy objects? Is that what I'm getting?
Yeah, I think the decision is to stick with the more modular policy objects. One of the big advantages of that is that you can authorize creation of those objects independently. So for instance, if you have someone who's in charge of resource management in the cluster and a different person who's in charge of security policy, then you can kind of subdivide that access. And also just makes the API a little more manageable. And I think that there's ways that we can still compose those policies together, taking advantage of things like pod labels in the bindings.
Yes, I think I would call out is in discussing the scheduling policy, the hardest questions have been around how policies are composed and then defaults. And where also is the line between what should be a policy and what is really just configuration, and how those should be managed. Anyone has thoughts on those?
Yeah, a lot of the things that Kubernetes does around like using labels and letting topology be arbitrary and letting you use topology for different things. So you can use it to represent like availability or locality or security boundaries. Like it's really flexible, but then turning it around and saying, oh, well, we obviously want to manage the security aspects one way and the availability aspects another way, but they're both kind of reusing this common mechanism. So the flexibility of the way Kubernetes does some of this is wonderful, but also gets really tough to write policy around.
Yep.
All right, Mike, do you want to talk about external ID?
Yeah, I just wanted to give a heads up. I think that we are on track to remove external ID from the cloud provider interface for 111, and that's the PR 60692. I think it's waiting for approval on package kubelet. And the follow-up PR, which is 61877, will remove it from the API, which is not approved and still needs to be reviewed. So I might be poking you, Tim, for approval on the kubelet bits, and then I'll start going through the process of getting approval for the API, removal of the deprecated API field. And at that point, we will be able to remove self-delete from the node ACLs.
Yeah, woohoo.
Can you sort of explain a little bit why this work allows us to remove self-delete?
Yeah, so Node has permission to delete itself right now, which is problematic for using taints for strong exclusion. For example, if you wanted to add a compromised taint to a node, the node right now could just delete its node object and recreate itself, and it would no longer have that taint, so they're not particularly useful. The only reason a node would ever delete itself currently is if its external ID changes, and basically no cloud providers, that basically never happens. And there were situations where it would happen, but 60692 removes those situations. They would happen during upgrades of the controller manager, basically, from older versions like 1.2 to 1.3 changed AWS's external ID, which required their nodes to delete themselves. And yeah, so we're happy to close down this gap that we've had for so long in 1.11. Does anybody have questions?
Is external ID captured by another field instead, or did we just decide that we don't need that?
Yeah, so basically the semantics weren't completely consistent. There's another field called instance ID, which for I think half of the cloud providers, the external ID method just called instance ID. For a couple of the cloud providers, they called the external ID called instance ID and added a slash, and GC and AWS were doing something a little weird. But the first PR in that list moves all callers to use instance ID, which is not deprecated.
And is mutable, if I understand correctly.
Yes.
Yeah, so the immutability of the field was the big issue. So now if a node comes up and whatever method it's using to determine its instance ID has changed, it can just update it. There's kind of ongoing discussions around provider ID and instance ID stuff and whether the data in the API is the source of truth or whether that's just an optimization to let you easily find the instance ID and then kind of verify it once you've found it in the cloud provider database. But those are sort of secondary discussions. The mutability lets the node do the update. And so that's the main thing we care about for this.
Although I am currently of the opinion that some of the efforts to decouple those are potentially solving a problem in the wrong way.
Yeah.
And that,
yeah.
All right, let's move along. Andrew, would you like to talk about TLS Bootstrap via TPM?
Yeah. So I shared the doc like about a week ago. Hopefully some people had a chance to read it, but the short version is this is a proposal for another way to for an improvement to how nodes bootstrap their client TLS credentials used to talk to the API server. The supported ways right now are either a manual approval, so node creates a CSR and then operator comes and manually approves, or using a bearer token, which just the possession of a bearer token grants any machine the ability to create a CSR, get it approved, and essentially join the cluster. That is not perfect because this token can be exfiltrated and it doesn't generally expire, even though you can make it expire. So the proposal is adding a TPM in the mix, which, if in case you're not familiar, it's a hardware, firmware, or software device that essentially keeps all the crypto secrets or private keys within its boundaries and exposes a set of operations like sign, encrypt, and so on. It's generally slow and doesn't have a lot of storage, but it's good to protect sensitive data. The way we use it is given a specially provisioned TPM that has a certificate signed by an external trusted CA. We send the certificate along with a signature of the public key, for the TLS public key is newly created, to API server, and that gives much more information about the identity of the machine. It has a much stronger proof of identity than just a bearer token to the API server. The only objections seen so far in the doc were to the proposed way of implementing this directly in the kubelet. Theoretically, yes, it's possible to implement the same thing using an exec authenticator plugin in kubelet, which just does all this like TPM magic internally and just spits out a finished certificate and private key. The only concern with that is that one future enhancement to the design could be to actually store the TLS private key within the TPM such that it's completely non-exportable. But that requires implementing a crypto signer interface in Go using TPM operations, which has to be done either directly in process or could be done using some external signing interface, but that's like another whole thing that's not currently implemented in Kubelet. Yeah, this whole design is not so trivial, so I'm happy to answer any questions, concerns.
So the concern, I think, for most of the stuff in the PR was that we didn't want to add specific fields to the kubelet so it understood this one kind of TLS bootstrapping flow, that it could include additional data in the CSR. We've sort of been moving towards authentication being that the credentials you authenticate with to be those evidence rather than the CSR itself. So the exec plugin things would allow you to authenticate, let's say, using an AWS credential. So the CSR would be the CSR, but the actual data inside of the CSR object or the Kubernetes CSR object would say this was created by node X, Y, or Z based off of how you authenticate that. The issues with this seem to be, so that strategy seems to work right now, except for the fact that the PRs that we have in flight for adding TLS support to the client or the exec plugins require you give a private key to hand over a private key in memory to client Go. Have you considered anything alternative, like having that private key signing a bearer token and then a short-lived bearer token and then using that instead to authenticate against the APIs?
I have not considered that specifically, but that having a private key that you sign some bearer token with would still require the API server to trust that private key or have some way to establish that private key in the first place. So I think that still has the same problem. I agree that having an exec auth plugin that uses some sort of cloud-specific API to prove identity is another possibility to do the same thing. It doesn't work outside of cloud environments. So the TPM stuff could be implemented on any on-prem cluster, since most modern servers will have a TPM device.
Have you seen sort of external plugin implementations of the crypto signer stuff that lets you drop in a non-exported key into a TLS chain in Go? I'm just curious if anything like that exists.
I was messing around. I didn't implement something like that with a TPM, just like as a simple POC.
Yeah.
I have not. I'm not seen it in Go specifically, but I know Mike has seen something in Boring Crypto.
Yeah, so I have, I think that Meek, who works on core DNS and is one of the GK SREs, has a GitHub repository that implements crypto signer using backed by a PKCS11 shared object, which is can access keys inside HSMs or TPMs, depending on if the hardware vendor implements the shared object. So that is done using the crypto signer interface. The Boring SSL, and it seems Boring SSL implements support for, actually OpenSSL implements support for something called a crypto engine, and it just calls out for signing operations, and Boring SSL and Istio went a different direction. Boring SSL also supports the crypto engine, but it supports something called a split handshake, where handshake messages in a TLS session are passed to a external server, and that way the entire handshake is offloaded, and the eventual symmetric encryption channel is I guess the key for the symmetric encryption channel is eventually handed off to the actual process, and the process then continues the TLS session. So there's actually a number of ways that people are doing this today. Crypto signer interface and the Go TLS stack right now support hardware-bound keys.
So Eric, as we're looking at the X509 pieces for the external exec, it would probably be worth kind of surveying the methods people are using that don't involve handing over the private key, and just thinking about how you might indicate that one of those would be used instead in the future if we wanted to add in support for those in the response from the exec plugin.
Yeah, there was a small amount of conversation on one of the PRs about this.
Okay.
I think it would require something like basically just implementing the signer interface with the signer interface through these messages that are being passed. So everything starts looking kind of, it's a pretty big change to sort of the flows that would go through that exec plugin.
We will also have to disable non-ephemeral cipher suites for TLS, unless we want to support a decryption interface as well. But I think that they are deprioritized because the non-ephemeral ones are deprecated and won't be in TLS 1.3 because they don't provide forward secrecy of the TLS channel.
So to say, I like this proposal. I like the idea of binding this attestation data into the CSR cryptographically, as an alternative to the way we can do it right now, as with the way you authenticate to the CSR API. I do think it's
too. It reduces the value of the credential that lets you submit the CSR.
Yeah, I'm a little concerned that this TPM specific bits are a little overly specific, and that it would be better to find an extension mechanism that also supported other kinds of attestation, like Eric mentioned, kind of like the cloud provider models where you have to do some funky API call and get a token or something like that. But in the end, you could still take some kind of assertion document and bind it into the CSR. And then this TPM thing is sort of just one example of that. Spiffy is also kind of tackling a bunch of these problems on AWS and some other cloud providers, and also for the TPM case. And that might be good to look at the APIs that Spire has there for node attestation is what they call it.
Having done this for sort of some of the AWS stuff, we were kind of skeptical about putting any data like that into the CSR because it's often just like some symmetric document that you have. So that's not data you're able to make public, which is why we were sort of going on the route of saying that authentication actually works, or doing this at the authentication layer with some credentials works really well, because then we don't have to publicly make available like the signed document or something.
So the problem with the bearer token approach is you actually, since the EK cert is chained from the vendor or provider of the TPM, you actually have to submit the EK cert, the signature of the key, and a number. I think correct me if I'm wrong, Andrew, but I think you also need to submit the attestation identity key cert, which is then used to sign the cert. So you end up with like a kind of a lot of data to be transmitting over bearer token auth, and then now you have like the token authenticator has to parse and do a chain validation of this encoded like numerous PEM documents or PEM blocks. It gets a little gross.
Yeah, another issue with that is you essentially sign the public key in the certificate in order to actually validate it. Whatever thing that does validation, you have to read the entire body of the CSR, which I believe the current like authentication pieces on the API server don't do generally. They only look at the headers. And yeah, Mike's correct. It's like in this specific design, it's extra 3 PEM blocks. So that's a lot of data.
It's basically supplemental information to the approver, and there's I think the shared token is reasonable for the node bootstrap role, but yeah, we just need a way of adding supplemental information to that CSR object.
And just while we're here, so we should definitely talk more about ways of introducing more information to the CSR. But while we're here and we have a PR with a looks good to me about the client certs, do we want to hold off on that PR while we're still discussing how we're going to deal with keys that we don't have access to, or do we want to see that through?
I think both are useful.
Yeah, can you link that in as well?
Yeah.
I think these are like separate features. They don't really overlap too much.
Yeah,
I mean, we've definitely seen requests for ways to protect client certs, so they're not just plain files on disk. So whether that's running them through GPG or like some encryption layer that requires like an initial session password to unlock it, and then can only be accessed via a script that goes through the GPG tool or some agent that is unlocked. And so adding TLS client cert support for the exec plugin helps with those cases a lot. Like where you're not interacting with a TPM, you just don't want unencrypted keys sitting on disk.
Is the motivation like protection against arbitrary read or directory traversal with arbitrary read, or what?
Yeah, I mean, it's the same reason your SSH key requires you to authenticate. So if someone steals your hard drive, they don't have all your credentials. They have, it's something like that.
This is a good conversation, but I want to make sure we get through the rest of the agenda. So I'm going to suggest that we continue this either asynchronously or schedule a follow-up.
Sounds good.
Excuse me. Mike, do you want to talk about service account token volumes?
Yeah, this is a pretty short one. This is a proposal that actually adds API types to an older proposal that we circulated. It adds a new volume projection that projects a service account token sourced from the token request API. So what that means is it'll look and act a lot like the current secret volume that we use to get tokens to pods, but it'll use the new API. So I think the weakest part of the proposal is probably how we deliver the CA certificate, which is required to maintain backwards compatibility to that old secret volume. Right now, it also proposes something called a public config map projection, where we look for config map in the kube public namespace, which we've used elsewhere, and then the token controller would maintain the config map with the CA cert in that namespace. I'm not really sold on that solution. So if anybody has ideas on how to improve that without going down the path of figuring out cross namespace config map references. I don't want to block on that discussion because I think we've talked about that for a couple of years now. Definitely please help weigh in on the design of this. I'm going to also present this at the next SIG storage meeting, which is Thursday after tomorrow. Any questions?
Is the eventual goal to deprecate shipping the CA cert bundle to every pod?
No.
Or is that something we want long term?
I mean, things inside pods need to talk to the API unless you mandate them talking to an unencrypted local port to do that. They're going to need trust somehow. Mm-hmm. I think what we're trying to do is remove the need to duplicate the CA bundle in 10,000 places. And so it seems like the trust bundle to talk to the API is something that the kubelet should be responsible for delivering. And so having that information in one place and either having an indication in the API that should be injected into a pod, or having that be implicit along with the service account token volume is kind of where we're going. So it's trying to figure out the best way to tell the kubelet where to get that data.
I guess what I'm getting at is whether that's something that we could just integrate into the service account token projection volume.
I think we definitely can. I've considered it. It seems potentially like we're conflating two things.
With the ability for service account tokens to have audiences other than the API server, it's a little wonky for like the trust bundle for the API server to kind of come in with that all the time, even though that is, I would guess, the vast majority of the uses of it. But it's slightly odd.
Mm-hmm.
Anyways, I'm gonna think about this over the next week or two, and try to think of an improved proposal as far as delivering the CSR. I don't think we need to go into much more detail on that here. We can move on to the discussions.
Yep.
All right. So I added this CRI Streaming Authentication piece to the discussion. So just to give a little bit of background on this issue. So CRI is the Container Runtime Interface for folks who don't know. This is the way the kubelet talks to the runtime that actually starts containers. And one of the features of that is exec, attach, and port forward. We call them the streaming APIs. Now, before the CRI, with the way this worked was just that the API server, the client opens a streaming connection to the API server, which proxies that through to a streaming connection to the kubelet, which then proxies that through to a streaming connection over Unix domain socket to the runtime Docker in that case. With CRI, we wanted to originally remove the kubelet as a extra proxy hop. And so the way I implemented this originally was that the CRI would return a URL to where it would start that server. And this actually also gives it the ability to start the streaming server in the pod C group to account the resources used by that stream to the pod. And so it returns that new location. and the kubelet then turns that into a redirect response to the API server, which gets redirected to the new server location. There's a bit of hackery in the API server to kind of inspect the return stream just enough to see if the header is a redirect and then follow that if necessary. There's some concerns about kind of that redirect flow, but that's sort of a separate issue. The main thing that I wanted to call out here is this now, since each CRI implementation is now serving these streaming requests, they need to have serving certificates for the API server to talk to them. Debatable whether there should also be a client certificate flow. The URLs that are returned are one-time use, randomly generated tokens, so that should be sufficient, I think. But we still need a way to get a server certificate to those.
It also means that they're binding to host visible interfaces. So like in the example, it's 127.0.1, but it would actually, for the API server to reach it, it would actually need to be an external interface.
Yeah, right. Yeah, so this is either exposing a new port on the kubelet, or sorry, on the host machine, or potentially opening a port in the pod network namespace. But no one is doing that today, and would probably have some issues. So the simplest option is presented here as or option 1, I guess, is to basically say, you know, this is all too complicated. Let's forget this whole redirect flow and just keep the kubelet as a proxy hop, and the CRI streams to the kubelet over Unix domain socket, and then we just rely on the kubelet to API server mutual TLS for that. The problem here is you do have that extra hop through the kubelet, and resources get attributed there. I think there was some originally some concerns about this. I'd like to see some benchmarking on what the actual overhead looks like. Or I guess there is some here, actually. But my thinking is sort of like this is a debug flow and shouldn't be used for high volume production traffic. I think if you wanted to kind of productionize this, there's a way to sort of start up like an SSHD server within the pod or something like that and go through an external ingress. Option 2 is basically to do a hybrid approach. I forgot to mention that another concern about this is the CRI Cuddle tool is for local debugging and needs to be able to connect to the streaming server using only credential or using a flow that's on the local host, just for purely for like debugging and maintenance of the cluster. Option 2 is sort of a hybrid one. I think it's probably more complicated than we want. And then option 3 is about keeping this redirect flow and figuring out a way to get serving credentials for the CRI. So are there any thoughts or questions about that?
Have you considered generating a certificate and sending the public key as well as the redirect?
Yeah, so one option, another option here, I guess, is get rid of this kind of hacky redirect thing and say just the kubelet has, this is an API call to get that endpoint, and the return is some sort of struct that includes both the new endpoint and the credential or serving public certificate that should be used when calling out to that. If we want to stick with this approach, I think doing something other than this redirect approach would be better anyway. The redirect was originally implemented to maintain backwards compatibility, but I think we could do that with just a fallback as well. So yeah, that's definitely an option.
It's a little scary to have a certificate signed by the root CA with the IP address of the node and hand that to the CRI. So I think a model where we do something like this before would be preferable to that.
My interpretation of the suggestion was that the CRI, maybe I misinterpreted this, but what I was thinking is the CRI shim would generate a self-signed certificate, and just in the response back to the kubelet, which gets sent back to the API server, would just include that self-signed public certificate, and then the API server would just make the request pinning that certificate.
That was a suggestion, yes.
Yeah. Yeah, so I was just making it clear that root CA signed certificate would be bad in that situation. I think that's actually, there was a draft that I'm not sure ever became an RFC called SPKI, which kind of details flows like that.
Okay.
Yeah, I think the trickiest part would be making sure that the API server had visibility, network visibility to the endpoint being serviced by the CRI. Because right now we've got one, maybe two, if you care about both of the kubelet ports that you have to make visible. And so it becomes a new port that firewalls and network rules and whatever else has to make sure they have.
Yeah, that comes back to option one being much simpler, and that includes a smaller attack surface as well.
Yeah, I mean, I'll be honest, I haven't heard of going through the kubelet being an issue with this. I mean, it's not, I agree it's not the nicest thing, but it just hasn't bubbled up as an issue, honestly.
Sorry, I think you cut out there for a second. You're saying the kubelet being a bottleneck hasn't been an issue?
I mean, a lot of the ways that these end up getting run, like you end up having something in between in the network that keeps this from turning into like a persistent production level, high volume tool anyway. And so it's much more typical for it to be, let me jump in and like run a couple shell commands or like copy a file out, not this is what I'm using to like tar multi-gigabyte backups off of my database pod. Like that's just not what people are using it for.
Yeah, well, there's probably someone using it for that.
Well, they're already disappointed, so.
Yeah, another thing is we could just put in more aggressive rate limiting on that as well.
Must we use lose the chargeback model if we do proxy through the kubelet? Is there no way to do chargeback or value-added tags to the C group?
It's going to be pretty hard to tease that out of the kubelet's usage.
Because Go or because kubelet or
I mean, if it's kubelet's process, I'm not actually sure how you would go about doing that. Anyway. Anyhow, I want to make sure that we have time to get to the governance proposal in the last 10 minutes. So maybe we can continue this discussion on that issue.
Okay.
So we sent out the initial governance proposal, I sent it out kind of late last night and just pinged the mailing list this morning, so I don't know how many people have had a chance to read through this. But I guess I can kind of talk through a few of the high-level points. I'll try and do that quickly so that we have time to discuss as well. So there's sort of three leadership roles that we've separated out in this proposal. The first is the chair, and the chair role is basically responsible for kind of the governing and sort of organizational bits of the SIG. Things like running the community meetings, managing some of the release coordination and communication across SIG, and generally just kind of like the running the business sort of pieces. This isn't a business, but I don't know if it was. The chairs would be responsible for that, I guess.
Sending out agendas, uploading videos.
Yeah.
Crossing T's and dotting I's, things like that.
Yeah. And so then the second role is technical lead, and this is kind of actually providing technical leadership for the SIG. And so things like establishing new subprojects, decommissioning existing subprojects, generally things that are sort of like fall within the SIG Auth umbrella, but are sort of maybe cross-cutting issues that don't fall neatly into a specific subproject area. The technical leads would be an escalation point for issues, and help kind of roadmap and think about some of the broader issues within the SIG, and also be contacts for cross-SIG issues there. And we put a number sort of arbitrarily at 3 to 7 for technical leads. And so I think historically we've sort of had the chair and the technical lead as a single role of SIG Auth lead. And now we're splitting those into 2 separate ones and growing the space for technical leadership. Anything to add to that one, Jordan or Eric?
Just to note that this is basically a tweaked version of the short form template that is being followed by most of the SIGs. So if you are interested, I think there's a link to that in the poll, so you can kind of see where we tweaked language or kind of clarified some things, adapted it. But in general, this is following that pretty closely.
Yep. And then the third kind of leadership role is the sub-project owners. And so these are the kind of more narrowly scoped leads of the specific sub-projects. We haven't really defined sub-projects here. We plan to follow it up with a document describing more what sub-projects are, how they're organized, and how they should be run. But these would be sort of the like domain-specific experts for the different areas within SIG Auth. There's a lot of overlap between sub-project owners and technical leads, and probably most of the technical leads will be sub-project owners as well.
And just to give a sense of like what a sub-project is, for other SIGs, this might be something that's like an external project to that SIG, like Cluster Lifecycle has a lot of things like kubeadm and bookube. We saw sub-projects as being sort of a lot of the in-tree implementations, like the authenticators or some of the token request work or something like that. So think of it more as the bits that we own already rather than new projects that are being spun out of Kubernetes.
Yep. We have a list, I can't pull it up right now, of kind of sub-projects that we're thinking about at the moment. So this includes things like audit logging, the policy area, authentication, authorization. Authentication may be broken up into smaller areas, node isolation. But we will we'll follow up that discussion in more detail at a later date.
I'll stick that link in the agenda as well.
Yeah, thanks. And then the last piece to call out are members. Members are basically people who contribute to the project in a kind of documented, sustained, concrete way. The privileges that membership comes with is sort of a voice in broad SIG direction. If we ever need to invoke voting, members would be the ones to vote in for different roles. But generally, this is just a way to have some formal recognition of sustained and valuable contributions to the project.
It's also helpful to know, like, how many people are there that are able to help in this area. So for planning purposes, you know, if there's one person who is interested in this area and they haven't been very active, then we should know not to plan on lots of work getting done in that area. But if there's 20 people that are responsive, then it helps knowing that.
I'm going to cut this off there. You can read the proposal on your own time, but I just wanted to make sure that we had time for discussion. I know we've sort of cut this short.
I don't know. Given how late this went out, I would actually say let's read this and comment in the poll, and then plan to discuss this in the next meeting, so we can give it the time it deserves. Agreed.
And we can try and get out a little more information on these sub-projects before the next meeting as well. Any questions about this or concerns in the last minute?
I would be interested in understanding the diff between the template. I think that would help me review it at least. It all sounds fine.
Yeah, I linked in the original template as as a diff-based sort of. Unfortunately, the diff, we sort of moved around and reworded enough that the diff isn't super useful. But if you're interested in kind of like a side-by-side comparison, you could get that through the second commit.
Cool, thanks.
All right.
All right, well, we're out of time, so that wraps things up. Thanks, everyone.